Okay, the multiplication rule of probability. The probability of A and B is the probability of A multiplied by the probability of B. So what's happening here is we're doing two different things. So let's just say I'm rolling a die and throwing the coin. I'm doing two different things, so A and B are different items. So let's just go, what's the probability of me throwing a head and getting a 6? So what's the probability of getting a head? What's the probability of getting a 6? Whoa, that was easy to do. A head and probability of getting a 6. Let's multiply a half by a 6 and get a 12. That looked really easy, didn't it? Always wise to check these things. Handy dandy two-way table, hey? Okay, head and a 6. How many possible outcomes do we have? 12. How many heads and 6s are circled? 1. So our two-way table confirms our application of the rule. So wherever possible, you want to be able to do your two-way table to validate and to look at it and to make sure that you are correct. However, sometimes you're just going to have to use the rule because you can't conceptualize it in a table. So you need to know both ways. You definitely need to know both ways. Let's do a bit of a longer one. Let's just go coin. Let's go the probability of a head and a head. Let's throw it 3 times. Probability of a head and a head and a head. Probability of a head is a half. Getting a head again is another half, and getting another head is another half. A half by a half by a half. An eighth. Seems simple. Let's just validate that, check for reasonableness. We're doing 3 things, throwing a coin 3 times, so we can't draw a two-way table. We've got to go to the tree diagram. I am going to shortcut it though, aren't I? How many possible outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 possible outcomes. How many of a head, and a head? Well, this one here, if we listed our sample space, this one would be head, head, head. All the rest would have at least one tail in it. So how many are we going to circle for head, head, head? 1. So that probability equals WOPO. 1 out of 8. So it actually confirms our application of the rule in longer situations. Oh goodness, we are going to love this because they just keep on getting a little bit harder. So now we start talking about conditional probability. So our probability of A and B goes from that to probability of A times the probability of B given that A has happened. So let's just go to the whole, I've got different coloured balls in a bag. Red, white and blue. 4 red, 3 white and 3 blue. In all the questions to date, the question has been clear that you might pick a ball out, take note of its colour, return the ball and then do it again. However, now we're going to start to say that I'm just going to draw 2 balls from a bag. So what's the probability of getting a red and a white? So the probability of red, there's 4 red out of 10 balls. When I go in again, given that I've already just picked a red, there are going to be, the probability of getting a white was 3 white, but there's not 10 balls in the bag anymore because I've taken one out. So there's not 10, it's 9. So when I multiply it, you've got to make sure that because they're not independent events, this second probability, the po bit of it, the possible outcomes will change. 4 3s are 12 on 90, which is 2 on 15. So make sure you read the question clearly. Are you replacing the ball or are you not? It also happens with questions in cards. Let's do a card one. You've got to know your cards. What's the probability that you selecting 2 cards and you get an ace and then you might get a king? So what's the probability of getting an ace? Well, there's 4 aces and there's 52 cards. The probability of getting a king, well, there's 4 kings, okay, out of 52. Well, it's not 52 cards anymore because you just picked an ace. It's 4 out of 51. And so you've written the rule, you've applied the rule. The next thing here, straight to the answer. I think it's that one there. Okay, so make sure you are looking for that conditional probability where you're not replacing the card. One last complexity as we're getting into year 10 and up. Let's go back to 4 red, 3 white, 3 blue. What's the probability of getting a red and a white? So in the early stages it's just a red and then a white. But when the question just says what's the chance you end up with a red and a white marble, technically speaking, you can actually get a red and then a white. Well, that's a red and a white. Or you can get a white or red. Just squeeze that in. So all that matters here, red and whites, red and white, and white and reds, red and white. Red and white. 4 out of 10, and white, 3. Now you've already picked one out, so it's 3 times 9. Or, the additive rule of probability, or is plus probability of white or red. White, there's 3 white out of 10 because it's your first time in, and a red, so there are 4 red out of 9 because there's only 9 left. Straight in, so you've stated your rule, you've applied your rule, straight to your answer, 4 out of 15. So I know that was a bit of a long video because we covered from simple all the way through to complex, but make sure you have a good grasp on everything. Don't overread a simple situation and apply it in a complex situation. And clearly you don't want to have a complex situation and try and apply one of those simple rules and getting it wrong. So make sure you do as many questions as you can.